Namaskar and welcome to StudyIQ. I am your friend Rahul Saigavkar. Let's continue our discussion of NCERT Science series. We are discussing NCERT Science textbook for class 10, and today we are going to discuss chapter 11, that is Human Eye and Colorful World. It's a very important chapter from exam perspective. Many MCQs can be created for UPSC preliminary examination based on day-to-day activities, day-to-day life, day-to-day observation. For instance, you ask a question, why does the sky appear blue? We'll get the answer from this chapter. Do stars really twinkle, or is it just an optical illusion? We'll get the answer from this chapter. So many such concepts would be understood from chapter 11. Now, before we head into this chapter, I hope that you have seen our latest discussion or latest class, which was chapter 10. There we discussed two important concepts, that is reflection and refraction. And this second concept of refraction is very important for us to understand this chapter. So before entering, let me give you a small recap of what we discussed previously. I hope you do remember this: reflection and refraction. Now in reflection, this is the mirror surface. This is the mirror surface. Now I told you reflection of a incident radiation or incident ray, it follows two laws. The first law is the incident ray, the reflected ray, and the normal to the reflecting surface, they all lie in a single plane. Along with it, for the reflection, the second law states the incident ray and the reflected ray, they have same angle. The angle of incidence is always equal to angle of reflection once that angle is measured with the reference of the normal. Please remember this. And we also spoke about refraction. Now refraction, there is no surface, but there is an interface between two medium. Refraction occurs when light passes from one medium to another medium. Now why refraction occurs? Refraction, the light ray which is traveling, it bends. Bending of light is called refraction, and that bending is because of change in velocity of light when it passes through one particular medium. And change in velocity occurs because of change in wavelength and not change in frequency, that we have discussed. We also established some facts, like when the light ray passes from a rarer medium to a denser medium, the light always bends towards the normal, and when it passes from denser to rarer, it bends away from the normal. Also, refraction has two laws. The first law is very similar to law of reflection. That means the incident ray and the refracted ray and the normal to the interface, all the three lie in a same plane. Apart from that, the second law is the Snell's law, that is the refractive index is constant. N1 sine theta 1 is equal to N2 sine theta 2. That means the sine of angle of incidence and the sine of angle of refraction is always constant. Now based on this, we discussed many other applications. We discussed about the lens, the spherical lenses, the concave lenses and convex lenses. I hope you do remember that, because this background is very important for us to understand the next snippets also. So let's move it to today's discussion, human eye and colorful world. But before that, I have a small notice for all of you. Those who have missed out the train for July, that means July P2I batch, you still have opportunity to join the August batch. I would say this is the okay time to join right now. The July batch was ideal. Right now also, say for another month, you have opportunity, because this would be one of the last batches for 2024. You will have 4-5 months for preparation of foundation, then we'll focus on prelims, and then we'll focus on answer writing. So do join our batch if you have not joined till now. Our morning batch is starting from 11th of August. It is available in 3 formats: English, Hindi, and in a bilingual format. Very affordable price. To get maximum discount, do use my code Rahul Life. If you have not enrolled till now, do enroll. If you know anybody who's looking for preparation, please spread the word about StudyIQ. All right, let's begin our discussion. As I told you, today's interaction is about human eye and colorful world. Now, even before this, in our standard 8th discussion, standard 9th NCERT, we have understood some concepts about light. I told about the luminous objects, opaque objects, transparent, translucent objects. We also discussed some insights or some idea about how human eye works. All right. So today we'll talk about that, and we'll gain more insight into working of eye. Along with it, we'll discuss about a very common feature. Right now, I'm wearing a spectacle. The question is, sir, why are you wearing this? We'll try to understand that as well. First, let's look at the human eye. Now, In a general life, we talk about our mobiles, right? A great mobiles. We say it is 10 megapixel, 20 megapixel, 50 megapixel. It has camera, right? It has multiple cameras. But I would say the best camera is our eye. Human eye is like a camera itself, and it is one of the best cameras in the entire world. All right. Now you are thinking, sir, how is it possible? How is it possible? Where is the image formed? Where can I see the image? See, if you look at the cross section of eye, light has to pass through your eye and some image has to be formed. Right now, what I can see a chair here. Now, if I have to see a chair, the image of the chair has to be formed somewhere behind the eye, correct? And it is formed on the retina. This retina is like the picture film, right? On which the picture is formed. And I am seeing exactly the same thing. The chair is the picture is seen on retina. How it happens? In our eye, when the light passes, and I told you already, we see things around us mainly because of reflection. The light is reflected from those surfaces and an image is formed, correct? Now, how it works? Eye has different components. The external eye has a cornea. Cornea, it allows the light to enter. From cornea, there is iris. Iris, it controls the movement of the pupil. That means how much light enters in your eye. It is decided by iris. Iris for every individual is quite unique. Then there is pupil, the black part in your eye through which the light passes. And behind these, there is a lens in our eye. There is a lens in our eye. This is a crystalline lens. Now, human eye lens, it has a very peculiar characteristic. The focal length of this particular lens can change to a limited extent, and this is achieved by these ciliary muscles. And you do understand that we have a complex connection with the brain, from eye to the brain, because we need to perceive things, and for that I have optic nerve. That means the image recognition happens basically through optic nerve. Now if you're thinking, sir, I want to understand further what exactly happens. So this is your eye. There is this white part called sclera. Now this sclera, it helps in providing proper environment for the eye. Sclera also protects the eyeball from any damage or injury. Now eyeball basically is this part, this rounded part that you have. The outermost part of the eyeball is your cornea. Now the cornea, as you can see here, this is the outermost layer. This is the cornea, the outer layer. This protects the internal parts. The internal parts are pupil and iris. The human cornea is approximately 2 to 2.5 centimeter in diameter. The cornea, it also helps in refraction of light. This cornea helps in focusing the light onto the retina. Now, the light passes through the cornea. Now, it has to pass through iris and pupil. Now, what is the job of iris and pupil? Both of these, they are responsible for controlling the amount of light that enters your eye. Pupil is this black part, and you do know that we understand the concept of pupil dilation. Pupil dilation means the pupil becomes bigger in size, or pupil contraction, the pupil becomes small in size. Along with this pupil, the iris muscles, they also move. Iris and pupil, they help in controlling the amount of light that passes through the eye. For instance, if there is too much light here, now if there is too much light, what happens is the iris, it consists of iris muscles. Now these iris muscles, they will expand. Now if the iris muscles expand, that means your pupil, that will constrict, that will contract. Less amount of light passes through it because already outside there is too much of light. And reverse happens when it is dark. If it is dark, I need more amount of light to pass through my eye. That means the pupils, they expand. If the pupils are expanding, that means the iris muscles, they are contracting. And these iris muscles, they are peculiar, they are colored. Now iris is the circular colored area. That color is because of your your iris muscles. And every individual has a unique iris print. Iris is like a fingerprint. You must have seen that you have given 10 fingerprints. Along with it, you have also given your iris scan. These iris muscles are unique for every individual, and iris muscles are responsible for the color of your eye as well. Some people have brown eyes, some people have blue eyes, some people have black eyes. It's because of the iris muscles. All right. Now, light has now passed through cornea. Then the proper amount of light has entered into iris and pupil. Now, I have to form the image. For forming the image, the light has to be focused through the lens. Now, this is the lens. This is the lens that we have, a crystalline lens. When the light passes through it, The job of this lens is to ensure that image is properly formed exactly on the retina. Please remember, it should not be formed in front of retina or behind the retina. If this happens, then you have some sort of eye defect. And that is why our eye lens, it has the capacity of changing its thickness. It can become thicker or thinner. As I told you, if you have a camera, you set the camera lens to focus on something. But human eye has already the ability to become thick or thin depending on your focusing. And this is possible because of your ciliary muscles, because this lens, it is connected to ciliary muscles, and these ciliary muscles, they ultimately help in thickening and thinning of the lens. If you have to focus on nearby objects, the lens becomes thicker. If you have to focus on far away distant objects, the lens becomes thinner. And ultimately, remember that the image has to be formed exactly on the retina. If it is being formed anywhere else, ahead or behind, you have some sort of eye defect. All right. Now, I understood, sir. Light has entered. If I have to see there is a chair here. If I have to form an image of the chair, what happens? I have to first allow the light to pass through it. That reflection is passing, and I have to create that picture. Now that picture would be created where? On the retina. I have to analyze the picture as well. And for that analysis, I have optic nerve. This optic nerve, it assesses what kind of an image is that, or what kind of an object it is, and it forms the image on my retina. And this retina is like a film. This retina is like a film, and this film has different kinds of cells. These cells are called photoreceptors. These cells are called photoreceptors. They receive signal from the brain. They receive signal from the brain via the optic nerve. Now, this is the optic nerve which is connected, and the image is formed. Let me just clear it up. The image is formed on this retina. On this retina, through the optic nerve, it analyzes the information and gives you that image. Now, retina has two kinds of cells, two kinds of photoreceptors. One are called cones, the other one called rods. Now, to remember these, please note that our retina, it has two cells, cones CO. Remember, if there were no cones in my retina, I would see everything is black and white, because cones are responsible for, first of all, colored vision. Apart from that, cones are responsible for my frontal straight vision, the central vision that I have. Along with cones, we have rods, the rod cells. These rod cells are responsible for the peripheral image that I have. You do know that human eye, it can see straight. It also has some sort of peripheral vision. I can see my own hand, but not focused. I am not focused on it, but I can see there are two objects here. It is because of the rods. The rods are also responsible for the black and white imagery as well. Now, apart from this, you need to remember that there is one particular blind spot in our retina. This blind spot is where the optic nerves connect with the retina. And that's why at this particular spot, there would be no image formed. That's why there is certain point in my retina where I cannot see my image. I cannot see the image because at this point, optic nerve is connected. So at this optic nerve, there are no photoreceptors, and that's why there is no image detection as well. All right. So this is basically the anatomy of our eye, inside the eye. Now let's talk about the eye image formation mechanism and some of the defects connected with our eye. Now, there is one concept connected to our eye which is called as power of accommodation. Power of accommodation. What is the meaning of this? I told you, human eye is the best camera that is available in the world. Why? Because human eye has the ability to focus on whatever thing you want automatically, within a certain limit, of course. Within a certain limit, automatically. All right. Now, how? Say for example, let me just pick up my mobile. All right. If I want to read something, now I want to read something on my mobile. If I hold my mobile this close, can I read? I cannot read. The same thing, if I hold my mobile far away from here, and can I read? I cannot read even now. That means human eye has a limit. Human eye has a limit of focusing. I can read anything properly. If I hold a paper, if I want to read, if I hold it approximately 20 to 25 centimeters from my eye, I can read it properly. I can focus properly. Now, this range of focusing of the eye, it is called as power of accommodation. And we have a natural power of accommodation because of the ciliary muscles. Human ciliary muscles in the eye, they tend to thicken the lens or thin the lens automatically, allowing us to focus on distant objects as well as far objects. Now this is called as power of accommodation, the ability of eye to adjust its own focal length because of the ciliary muscles. It is called as power of accommodation. Now many a times what happens is this power of accommodation, it becomes weaker. Why? Our ciliary muscles might get weak, or there might be some other problem with the eye, and that is when problem occurs to us. As I told you, the image has to be exactly formed. If the light passes through it, the image has to be exactly formed at the retina itself. If the image is formed somewhere inside the eye or outside the eye, then you have eye defect. Now what are these eye defects? We have eye defect called as myopia. Now myopia, it is basically known as nearsightedness, meaning if a person has myopia, that means they can see nearby objects very clearly, but they cannot see distant objects clearly. Now this is very common, especially in youngsters these days. We see a lot of people having these spectacles. I also have one, right? I also have one. In fact, when I went to doctor, my eyes were being tested. The doctor told me I have astigmatism. This is another peculiar case. That means I told you image has to be formed exactly on retina. Both the eyes have to form at the same spot. Now the doctor told me you have astigmatism. Your image, one is proper, one other image from the eye is not being properly created. So what you need is a correction for one eye. So I have problem in one eye, right? I don't remember the exact power, but there is one problem, one eye has problem where the image is not being formed properly. So if you ask me, sir, if you remove your spectacles, can you see? Yes, I can see properly. I can read properly also. But sometimes when I read, I have to focus a lot, which might lead to a little bit of headache sometimes, right? But nonetheless, what is myopia? Now this myopia, it is a situation where a person can see nearby objects very clearly, but if it is far away, they say I can see it, but it is very blurry for me. That's when you go for your eye testing. That means the image, it has to be formed properly at the retina. This is the normal image, but what is happening is the image is being formed somewhere else, and for that you need correction. Now this might happen because of problems with your ciliary muscles, problems with the curvature of your eye lens, or it can even happen because of the elongation of eyeball. Now in such a case, what can you do? You can simply use a concave lens. You can simply use a concave lens. Why? If I use a concave lens, that means what my understanding is, the image is being formed in front of the retina. I want to make sure that it is formed exactly at the retina. That means I have to focus the light, or I have to expand the light and focus on the lens, my natural lens, properly, so that image is formed here. That is myopia. The opposite of myopia is hypermetropia. Hypermetropia is called as farsightedness. It's called as farsightedness. Now, farsightedness means a person can see distant objects clearly, but they cannot see nearby objects very distinctly. Now this happens predominantly, I would say, at a little older age, somewhere around 40, 45 approximately. These days, any kind of problem is coming at any age. Why? Because of the use of digital devices. But in general, myopia is seen at a younger age, and hypermetropia is seen a little later, somewhere around say at the age of 40. Now what is happening here? That the image that has to be formed properly here, it is formed beyond the eye. It is being formed outside the retina. Now in such a scenario, if I have to make a correction, I have to simply use a convex lens. Now using a convex lens, I ensure that light is properly focused on my natural lens. Using it, image is formed on the retina. Apart from this, many people can have both. Now this is called as presbyopia. The name itself, presbyopia. Now presbyopia means the power of accommodation has gone down, meaning a person is facing both the problems. They are facing a problem of viewing the distant objects very clearly, problem there also, and also problem reading things. Nearby objects cannot be seen very properly. This is called as presbyopia. Now presbyopia is very prominent, especially in old age people. You must have seen old age people that they have problem with both. And how do you get a correction there? Because now the power of accommodation is now problematic. The ciliary muscles, they have become weak. So what happens is they have to put in too much of effort to form an image. Distant image, there is a problem. Nearby image, there is a problem. So what do? You go for a bifocal lens. You must have seen many people wearing these kind of lenses, right? These kind of lenses where there is correction for distance here and there is correction for nearby vision here. Do you have any elderly people at your home who have dual kind of lenses? Right now I do not have a dual kind of lens, right? My problem is mainly with the distant vision, is right now with the distant vision. All right, again, distant vision also I can see, but I have to focus, which leads to a little bit of headache. So probably when I enter my old age, there would be another lens at the bottom. For reading you have to view from that, and for watching something else you have to read from the upper lens. You must have seen them. Those are called bifocal lens. All right. Now, apart from this, you need to note one more thing, that eye donation can be done. All right. Even if a person dies, for approximately 3 to 4 hours, eye can be removed and eye can be donated to someone else. All right. So, did you know that eyes can live even after our death? And if we can donate our eyes, then someone else can get that vision. Please note that eye donors can belong to any age or any group, any age group, any specs. People who wear spectacles, they can also donate. People who do not wear spectacles, they can also donate. Please remember this particular point. MCQs can be formed on this simple question. People who have eye power, they cannot donate eyes. Nothing like that. People who have cataract, they cannot donate. They can also donate. Right? Anybody can donate. All right. People with some sort of disease like hypertension, asthma patient, etc., they can also donate eyes. The only thing is that whenever there is death, eye has to be removed within 4 to 6 hours. The eye bank team will come. If you contact them, if you decide to donate your eyes, just contact the eye bank team. They will come, they will collect the eye without disfigurement. They can do it properly through a simple procedure at home itself. These days that facility is available at home itself. After death, you simply have to sign a consent form. Please remember, who cannot donate eyes, right? People who are infected or who have died with AIDS, who have died with hepatitis B or C, who have died with rabies, who have died with leukemia, tetanus, cholera, meningitis, encephalitis, they cannot donate eyes because it ultimately spreads to the other person to whom it has been donated. It leads to problems. All right. Right. Now, apart from this, let's talk about some natural colors. Since we have understood about the anatomy of eye, now we'll try to understand about the colors. Now, we have understood the concept of refraction in our previous class. In fact, I began our discussion with this itself, right? The idea, reflection and refraction. I explained to you. Now, when you see refraction through a prism, this is just one surface. Please remember, this refraction is only through one surface. Now, let's talk about refraction through prism. Now, prism has 3 surfaces. Prism has 3 surfaces, correct? Now, as the light enters here, it will be refracted. It will be refracted. The correct path of this light would be in this particular direction, but that does not happen. Now, it is refracted. It is refracted in this direction. Now it enters, or it is at the second interface. Now, when you look at the second interface, it will again be refracted in the same direction. Now, through a normal prism, you will see that the light which enters, it exits in a similar kind of direction, just in the opposite. Now, light was incident in this way. Now, if you look at this in the opposite direction, it is refracted. Now, this is what happens in a normal prism. But if we pass sunlight or white light through a glass prism, we will see that a white light of beam, when it is incident on a prism, it will break into its constituent colors. That is what we call as the colors. We can remember them by the acronym VIBGYOR, VIBGYOR, right? White light, the sunlight, it comprises of 7 colors: violet, indigo blue, green, yellow, orange, and red. This is in the order of increasing wavelength. All right, from 400 to approximately 750 nanometers or 800 nanometers also, because that is the visible range that we have. When we pass white light through a prism, it breaks into its constituent colors. Now, there were some experiments conducted. A prism can break a white light into its constituents, the seven colors of the rainbow that we call. Now, there were some experiments that can we further break these lights? Can we further break these lights? For instance, if I place another prism here, can I further check the constituents of red light as well? That was not possible, and this experiment was conducted by Isaac Newton. Isaac Newton first thought that if a glass prism is able to give me the spectrum of sunlight, which gives me seven colors, now can I go further? And through another prism, if I introduce, can I see the constituents of red light? Can I see the constituents of yellow light? Can I see the constituents of other colored light? He tried to run that experiment, and he understood that if white light is passed through a prism, it is refracted, and the constituent light comes out, seven colors, and those seven colors, if I put another prism, they will again combine to give you white light ultimately on the screen. So what we realized is white light comprises of only seven colors, and these seven colors are the VIBGYOR colors. All right. So white light comprises of these seven colors, we established. And many a times we see the phenomena of refraction in atmosphere itself. You must have seen a rainbow. Now, what is this rainbow? Rainbow is a very natural process. You must have seen that whenever there is rain, and if there is sunlight also available, you will get a rainbow. Rainbow, it has seven colors. Again, VIBGYOR colors. Why that happens? Now, that happens because the rain droplets that are in the atmosphere, they act as a prism itself. The sunlight passes through a raindrop, it gets refracted, it gets internally reflected as well, and then the constituents of white light can be seen. And you will see that the rainbow can always be seen in the opposite direction. If sun is towards this side, on the opposite direction, you will see the rainbow. So rainbow formation is because of multiple phenomena. The white light breaking into its constituent lights, it is called as dispersion. The white light, it disperses into its constituent colors. So rainbow is formed because of dispersion of light. It is formed because of internal reflection, and it is also because of refraction in the rain droplets. Now, apart from rainbow, we see many phenomena in atmosphere. Because of refraction, we see so many phenomena. The first phenomena is the twinkling of the stars, the phenomena of apparent shift of objects, especially celestial objects. For instance, if I look at a star, we see that the star is in some apparent position. Now, because of which we see, of course, the light has to pass from the star. It has to travel millions of light years, and then it enters Earth. Now, if I view a star, I will always see its apparent position, and by the time light enters our atmosphere, that light is refracted, and because of which I see twinkling of stars. Twinkling of stars is because of continuous refraction of that light from the star. I'm talking about starlight, not the sunlight. Starlight being refracted continuously in my atmosphere, it leads to twinkling phenomena. Apart from that, I also see, if I'm looking at a particular star, that is probably the apparent location of that star. All right. In fact, we discussed in our previous classes that probably the light that is coming from the star, that might be past, because it takes a lot of time to reach Earth, and by that time the Earth is also revolving around the sun. Earth is rotating on its own axis as well. That's why we saw the light coming from the stars, that might be the light from the past, right? Now, apart from this, we also see some other phenomena like advanced sunrise and advanced or delayed sunset. You see, because of the refraction through atmosphere, we get an early sunrise. The sun is visible almost 2 minutes before the sunrise itself. Before actual sunrise, we can see the sun, and after the sun has set, we can see sunset for another 2 minutes. This is again because of the phenomena of refraction. We see early sunrise and delayed sunset due to the apparent position of sun or apparent location of the sun. Again, refraction through the atmosphere. Apart from this, We also talk about this scattering. Light, when it enters atmosphere, it is scattered. Light interacts with different particles. Now our atmosphere has different particles. It has dust particle, it has glass, it has not glass, it has gas molecules, etc. So light interacts with these impurities, dust, and light is scattered. Light is scattered. Now this scattering, it ultimately depends on the size of the molecules, size of the particles. If the size of the particles, it matches with the wavelength of the particular light. I told you, white light, when it disperses in 7 colors. 7 colors are different wavelengths, and a particular wavelength can interact with particular molecule, then that light would be more scattered. And that is why we see this phenomena. We see the Tyndall effect. We see that when a light source is passed through complete or a perfect solution, light is not visible, light is not scattered. But if you pass through a colloidal solution or a suspension, you will see the scattering of the light. Why? Because the light, because the molecules or the atoms in this colloidal solution suspension, they interact with light and they scatter. And very similar phenomena happens with this also. We see that sky is blue. Why is sky blue? Why is sky blue? Is only blue light entering Earth? No. White light is entering Earth. But Earth's atmosphere has different kind of particles, and these particles, they interact with light in such a way that they scatter blue light the most. So I can only see the blue light. And the other light, it is not being scattered, it reaches me. But scattering scattering at some height, it leads to that blue look. All right. Why? Because the size of blue waves and violet waves especially, they are just the right size to hit and bounce off the molecules of gas and molecules of dust and water molecules in the atmosphere, because of which we see blue sky. Now you must have a question. Sir, you said that sky is blue on Earth. Is sky blue on other planets as well? Not, that depends. That depends on the atmosphere of that particular planet. In fact, NASA's imagery has shown us that sky in Mars is different colored. Sky in Mars is a little different in color. Now these are some of the pictures of Mars. They have shown that the sunset there is actually of opposite of what you would experience on Earth. All right. During the daytime, the Martian sky, it basically takes reddish or orangish color, but the sunset in the sky, it has a bluish tinge. So what we see on Earth, its reverse can be viewed, or its reverse has been pictured from the Mars. All right. Now apart from this, there is one more phenomena. Because of light, we do see that sky is blue, but during sunset and during sunrise also, we see the sky becomes a little reddish or orangish. Why? Why does this happen? See, this is because as the sun gets lower in the sky, the light passes through more and more of atmosphere. That means blue light is scattered even more. Of course, blue light is scattered. Blue light is scattered multiple times now. By now, it has scattered multiple times. It allows red and the yellow lights to pass through our eyes straight, and that is why it looks reddish to us. Again, this is I would say an optical illusion itself. Is the sky turning red? Is the sky turning orange? No, it's only because of the interaction of light with the dust, water molecules, different pollution, right? So larger particles of dust, pollution, water vapor, atmosphere, they reflect more and more of red and yellow, because now the blue light has already interacted, it has scattered more, so I cannot see blue. I do see this scattering. The scattering of red and orange is more visible during the daytime or during the morning time, and especially during the evening time. That's why we see sun also appears reddish, the sky also appears reddish or orange. All right. Based on this, many times questions have come in form of MCQs. Please note these down. All right. That's the completion of this chapter. We'll continue our discussion in the next session. Thank you very much. And if you have liked this session, you can always follow me on this particular ID at the rate Rahul Sai 222. Thank you again. Jai Hind.